Hello, this video is going to take you through the 2.2 notes on domain and range. I'm hoping that you will be able to state the domain and range of both a relation and a function by the time we are done here. So it says to choose the following words from our last lesson. So we learned that the domain refers to the x variable, otherwise known as the independent variable. I'm going to abbreviate, or the input. The range refers to the y variable, or the dependent variable. I'm going to abbreviate there too, or the output. So here's a few examples. Find the domain and the range, and then is this a function? So the domain are the x values. So I'm just going to list the domain, and I'm going to use a little bit of a fancy little squiggly bracket. So just a curly bracket, and then list the values in the domain. 5, 2, 1, 0, 7. Just got commas in between them. The range would be the y values. So we have 3. 3 is listed twice. I don't actually have to list it twice in my set here. So I'm just going to list 3, 7, whoops, got the 5 first, 5, 7, and 1. Doesn't have to be in order. And again, if a value occurs more than once, you don't have to list it. If I look at my inputs, every input is matched with an output. So yes, this relation is more specifically a function. I'll let you do B on your own, and we'll skip to C. C, again, my domain, the values of my inputs, which are 1, 4, 13. My range are the values of the outputs, which are 8, 4, 0, and 12. And this is also, oh, I'm sorry, this is not a function. The problem is this input right here. It has 2 different outputs for a given input. This is not a function. Remember, in order to be a function, every input has to have just one output. And this guy is causing us a problem. Okay, and I'll let you do D on your own as well. I don't want to make this video too long. So when we're looking at domain and range from a graph, remember that in order to be a function, each input can have only one output. We can test this on a graph by doing something called the vertical line test, also known as the VLT. So what the vertical line test says is that if you can draw a vertical line on the graph, and if it only touches the graph once, one place, only in one place, or it isn't a function. So here's some examples of some graphs. This graph here, the first example, you can see anywhere you draw a vertical line, it only touches the graph in one place. So we say this guy passes the vertical line test and is a function. Same thing with here. This is an example of just one of the vertical lines, but anywhere you draw it, it only touches the graph at one place. So this guy is also a function. Right here, this is an example of a graph that fails the vertical line test. This vertical line crosses the graph here, here, and also down here. So this means that for a given x value, let's say, for example, this vertical line had an equation of x equals 3. That means when x is 3, y is this, and this value. So we have 3 different outputs for the given input. So that's why that is not a function. So moving on, when you're looking at a graph and asked about domain and range, the domain, you're looking at the graph horizontally. Remember, domain describes the x values. So you're looking at the graph horizontally, And you're asked, does it go on forever, or is there a starting or stopping point? So you're looking at to the left of the graph and then to the right of the graph. This is saying the same thing, but saying that the x values might not be included. Notice these are just greater than and less than signs, not or equal to. With the range, you're looking at the y value. So you're looking at the graph vertically in the vertical direction. And then we describe them with the y values. Does the graph go up forever? Does it go down forever? So again, you're focused on the y's of the graph when you're looking at the range. So let's do a couple of these. If I look at this graph in example 1, if I look at the graph in the horizontal direction, I can see that there is a smallest point for x and a largest point for x. So look at where these are. This point here, the x coordinate of that point is positive 6. The x coordinate of this point is negative 6. So these x values for my domain are between 6 and negative 6. Notice these are filled in dots, so I have the greater than or equal to. Now when we're looking at the range, we're looking at the graph vertically. And I'm going to describe it with y values. So if I look at the graph vertically, let me see if I can change color here. If I look at the graph vertically, I can see that this is the highest point on the graph. And I can see this is the lowest point on the graph. So my y values are below this point here, which is 6. So y is less than or equal to 6. And they're all bigger than this point right here, which has a y coordinate of 0. So my range is y is less than or equal to 6 and greater than or equal to 0. Does this graph pass the vertical line test? Yes, it does. So it is indeed a function. Let's look at one more example from this grouping, and then I'll have you try the rest on your own. So let's look at example 4. We have a circle. So again, when we're looking at the domain, I'm looking at the graph in the horizontal direction. My x's, this is the largest value of x, the farthest point that's to the right on the graph. This is the smallest value for x because it's farthest to the left. So my x's are between 4 and negative 4. So x is less than or equal to 4, greater than or equal to negative 4. Now when I'm looking at my y values, we'll do this in blue. If I'm looking at my range, I'm looking at my y values. So I'm looking at the graph in a vertical sense, looking for the highest point on the graph, which is here, and the lowest point on the graph, which is here. So my range, my y values, are less than or equal to this high point, which was at 4, and greater than or equal to negative 4, which is this low point. Is this graph a function? Does it pass the vertical line test? No, it does not. So if I draw a vertical line here on my graph, it hits in 2 different places. This is not a function. So I'm going to let you do the rest of those on your own for some practice. And we'll do a couple examples here on this last page, just so you know how to get started. So this is asking if the following relations are functions, and then state the domain and range. So even if the relation is not a function, I can still state the domain and range of it. Let's change back to a different color. So is this a function? In other words, does every x value have exactly one y value? Do you see that there's a problem here? Here in this first ordered pair, x is 1, and it's matched up with negative 2. Down here, I have the same x value, the same input of 1, and now it's matched with 3. This is not a function because the input of 1 has 2 different outputs. But again, I can still state the domain. It's supposed to be a curly bracket. So you list your x values. 1, negative 2, negative 1. And again, I put a comma there, but I don't have to list my second value of 1 because I already listed it here. For my range, I'm listing, yep, the y values. So -2, 0, 2, and 3. Let's do one more. Let's do example 5 down here, which asks us to write the relation as a set of ordered pairs. So we're just going to take these points and we're going to list them as ordered pairs. I'm going to start with this guy on the left. I'm going to change the color. It's kind of hard to see. Okay, so these points are -2, 2. That's this guy here. This one is -1, +1. This guy here is 1, 0. The one above it, running out of room, is 1, 1. This guy here is 3, -2. And this last one looks like 3, 3. So there's all my ordered pairs. The domain would be just the x-coordinates of each of these ordered pairs. So -2, -1, 1, and 3. So it's my bracket. And then my range would be the y values of each of the ordered pairs. So -2, 1, 0. I don't need to list the 1 again, and then I have 3. Is this a function? You can either tell by looking at the ordered pairs that it is not. I've got a couple situations where I have the same input right here matched with 2 different outputs. That also happens with the points here that have an x-coordinate of 3. You can also see this does not pass the vertical line test. Here's an example of where it does not, and here's another. We only need one example of where it fails the vertical line test. So this guy is not a function. So that's a no. So I hope that's helpful to you.